Today we're going to be talking about section 6.6, perform similarity transformations, and we are on page 22 of your notes packet. So go ahead and take a moment, pause the video, copy all your vocab, and then we can get into this. Okay, awesome. So today we're talking about transformation. So dilations, that's a shrink or a stretch. The center of dilation is just the fixed point about which the figure is enlarged or reduced. And then the scale factor of dilation is the ratio of a side length of the image to the corresponding side length of the original figure. All right, and then a reduction just is a dilation with a scale factor between 0 and 1. An enlargement is a dilation with a scale factor greater than 1. And then a transformation, instead of changing the shape of the figure, it takes the figure and it moves it in a certain direction, up, down, left, right, horizontally, vertically, so on. All right, so now let's go ahead and get into our key concept. So we can describe a dilation with respect to the origin using this notation here, okay? And so this is key, right? So what do you notice that changes? All right, so we're starting with our order pair xy, and then we have a multiplier, and our multiplier is k. That's our scale factor, right? And so if k is less than 1 and greater than 0, meaning if k is a fraction, a decimal, right, it's going to be a shrink. As opposed to if k is greater than 1, it's an enlargement. It's a stretch. So the figure is getting bigger. So if we look at example 1, where it asks us to draw a dilation with scale factor greater than 1, right? So they're giving us the coordinates for our quadrilateral ABC and each of the vertices. So we have these here, and then they told us that our scale factor is 2. So I'm going to have 2 times x, 2 times y. So 2 times 2, comma, 2 times 1, which gets us 4, 2. And then we have 2 times 4, 2 times 1, which gets us 8, 2. 2 times 4 again, 2 times negative 1, 8, negative 2, 2 times 1, 2 times negative 1, so 2, negative 2. And then if we go ahead and we plot these points, right, so I have over 4 up 2 right here, I have 8, 2 here, 8, negative 2 here, and then 2, negative 2, and then if I connect them, you can very clearly see, right, how the figure has been stretched, right? It's gotten bigger. And that's all that the transformation is doing, right? And so if you think back to when you learned about transformations in Algebra 1, this is essentially a vertical stretch or a horizontal stretch, all right? And so now let's go ahead and let's look at another example. So go ahead, take a minute, pause the video, read the example, and then we can pick back up. Awesome. So we have our triangle. We've already plotted it, right? Now we have a dilation of a scale factor of 1/2. So that means that our figure is going to get smaller, right? We're going to multiply every ordered pair by 1/2. So this is going to turn into 2, negative 2. This is going to turn into 4, 1, and 4, negative 2. So then if we go ahead and we plot our points, right? So then this becomes our figure. Great. And so you can very clearly see that it's been shrunk, and that is basically what we're asked to identify. So then you're going to go ahead and complete this extra practice, examples 1 and 2, on your own. All right, and so now let's look at example 3. All right, so find a scale factor. Go ahead, take a minute, pause, read, and then go ahead and try to set this up on your own. Awesome, so we're making photo stickers. So we're taking a photo that is 4 inches by 4 inches, right? So it's a square. And then the image on the sticker is 1.1 to 1.1 inches, all right? And then it says, what is the scale factor of reduction, right? And so when it says reduction, that means that the image is going to get smaller. So we need the smaller number to in the numerator and the bigger number to go in the denominator. So this is how we should set it up, sticker to photo, right? And so then from here, we know that it should end up looking like 1.1 over 4, but it's not considered proper to leave a decimal in a fraction. And so if we multiply both the numerator and the denominator by 10, that's how we end up with 11 to 40. And that's what the answer for this problem should be. Awesome. So now let's go ahead and move on. Reading diagrams, we can kind of gloss over that and look at example 4 for the really practical application. So go ahead, pause, read, and then we can get into the topic of this problem. All right, so it's asking what are the coordinates of point H? And so first we want to look at the points that we've been given, right? So here we have point R, right, 0, 2, point P, 3, 0. And so point R is mapping to point G up here. And so that's at order pair 2, 4, 6. So at 0, 6. And so here we would have multiplied by 3. All right, and so now let's see if that holds true when we map point P to point E. So now I'm looking, okay, I'm starting at 3, 4, 5, 6, 7, 8, 9. So 0, 9. If I multiply by 3 again, yes, that scale factor holds true. So now we know our scale factor is 3. And so if it's asking us what are the coordinates of point H, and point H is going to map directly to point S. Notice how they match, right, in the order of our similarity. So here's point S, which has an ordered pair of 1, 2, 3, 4, up 1, 2, 3, 4, 5. So we have 4, 5 is point S, and if we multiply that by 3, we're going to end up with 12, 15. And so that's the correct answer for this problem. Great. So you're going to complete extra practice example 3 on your own, all right, and the same thing with extra practice example 4. And then please zoom in if you have any questions on today's